Have you ever just stopped and wondered what everything around you is actually made of? I mean, the air you're breathing, the screen you're looking at right now. Well, today we're going to dive right into the story of stuff. We're talking about the basic rules of chemistry that literally shape our entire universe. Let's jump in. So, first things first, the biggest idea we need to get our heads around is that chemistry isn't just something that happens in a lab with bubbling beakers and white coats. Nope. It is the silent, invisible engine that powers, well, everything. The universe, life, all of it. I mean, just look at this. A new life breaking out of its shell. It's an incredible moment, right? But this isn't just biology. It's a full-on symphony of chemical reactions. The energy it needs to break through, the way the shell breaks down, the formation of its tiny bones and tissues, that's all chemistry in action. You see, at its heart, chemistry is really the story of transformation.
So let's put a nice, clean definition on that. Chemistry is, quite simply, the study of matter. You know, the stuff that everything is made of, and all the ways that stuff can change.
Okay, so that kind of begs the question, right? If everything is matter, then what is the matter made of? Let's zoom way, way in and take a look at the fundamental building blocks of, well, everything. Now this is wild. You might think the universe has this super complex recipe, but get this, it's incredibly simple. It's almost all hydrogen and helium. That's pretty much it. But then you look at our little corner of the cosmos, Earth, and it's a completely different story. Our planet's crust is this complex cocktail with oxygen and silicon running the show. It just goes to show you, location is everything. The ingredients you have to play with are totally different depending on where you are. So how do you get all the amazing variety we see in the world from a pretty limited set of ingredients? Well, here is an absolutely brilliant way to think about it. Think of atoms like letters in an alphabet, right? You only have 26 letters, but with them, you can write every single word, every book imaginable. It's the same idea with atoms. With just 100 or so different types, the universe can build everything from giant stars to tiny starfish. Okay, so if atoms are the letters, how do they start forming words? You know, how do they combine to make up all the substances that we can actually see and touch every day? Let's take that next step. So some atoms, like helium over here on the left, are kind of loners. They're perfectly happy to just float around by themselves. We call them noble gases. But most atoms, they're way more social. They actually prefer to pair up, kind of like these two hydrogen atoms on the right. And when they link up like that, they form a whole new kind of particle. And that new particle has a name you've definitely heard before, a molecule. This is our next level of complexity. A molecule is just a little team of two or more atoms that are chemically stuck together, acting like a single unit. Now, let's look at how these molecules behave, using an example we all know, water. Whether you've got solid ice, liquid water, or steam, the actual H2O molecules themselves are identical. The only thing that's different is how they're arranged and how much they're zipping around. In ice, they're all locked into a rigid structure. In steam, they're just flying all over the place. And the way we get them to change from one state to another, melting ice or boiling water, is all about energy. When you add heat, you're giving those molecules more energy to move around. When you cool them down, you take that energy away. We call this a physical change. The key thing to remember is, even though it looks totally different, its fundamental identity, H2O, hasn't changed one bit. All right, so that's how a single substance behaves. But things get really interesting when we start combining different substances. So what happens then? First, let's talk about the simplest combo, a physical mixture. The main idea here is that the ingredients are just stirred together. They aren't chemically bonded or changed. It's like a salad, right? You've got lettuce, tomatoes, cucumbers all in the same bowl, but the lettuce is still lettuce and the tomato is still a tomato. This is a perfect illustration. So we've mixed some yellow sulfur powder with tiny little iron filings. Now watch. The magnet pulls the iron right out. Easy as that. Why? Because it's still iron. It's still magnetic. And the sulfur is still yellow. In a physical mixture, everything keeps its original properties, and you can usually separate them out again pretty easily. But what happens if we take that exact same mixture and we add a little spark, a little bit of energy? This is where the real magic of chemistry begins. This is how we create something totally new. Okay, so we take our iron and sulfur mix and we add some heat. Whoa, look at that! The whole thing starts to glow on its own. That intense light and heat is a dead giveaway that a serious transformation is happening. This is not just a physical change anymore, not by a long shot. And here it is, the result. We're left with this single, dark, solid lump. Now, for the moment of truth, we bring the magnet close and nothing. Absolutely no effect. The iron's magnetic property, it's gone. The sulfur's bright yellow color, gone. Why? Because they're not iron and sulfur anymore. They have undergone a chemical reaction to become a brand new substance, iron sulfide.
So let's break that down into a simple recipe. A chemical change. Step 1. You start with your ingredients, which we call reactants. Step 2. You add a little kick of energy, like heat. Step 3. The atoms totally rearrange themselves to form a new product. And the most important part, step 4. The original properties you started with are gone, replaced by something completely new. That, in a nutshell, is a chemical change. This little flow chart here does a great job of tying it all together. See, at the top, you've got all matter, and it basically splits into two main categories. On one side, you have the mixtures we talked about, where things are just physically jumbled together. And on the other side, you have pure substances, which can be simple elements or the new compounds we create through those powerful chemical reactions. And what's so cool is that these rules are totally universal. They apply to that ostrich chick breaking out of its shell, which is powered by reactions, and they apply to super high-tech industrial processes, like using advanced chemistry to pull super strong titanium metal out of ordinary rock, so we can build things like airplanes and medical implants. So I'll leave you with this final thought. We've just gone over the basic alphabet and grammar of all the stuff in the universe. So the question is, when you look away from this screen, at the coffee cup on your desk, or the rain on the window, or even just the air you're breathing, what chemical story is unfolding right in front of your eyes? Thanks for tuning in.